In this lecture, we will be discussing two different techniques in chemistry used to take out certain compounds and purifying them via sublimation. As always, please do read the textbook. There's a lot of very interesting and useful information in there. Caffeine is a white crystalline solid. It has a bitter taste. You'll find out that there's a lot of things with caffeine in them whenever you buy coffee, tea, or soda. Any of those things all contain caffeine. Americans consume a lot of caffeine. We consume about 150 milligrams of caffeine daily. One interesting thing you might want to find out is why do we take caffeine into our bodies? So that's a very interesting thing. It has something to do with the pK of the caffeine. The chemical properties of caffeine are it's soluble at room temperature, but only moderately. When you boil water, it becomes a lot more soluble, and it is completely soluble in DCM. Remember the polarity, right? This is a pretty polar compound, and DCM is also very polar. But the thing is, with tea bags, there's a lot of other stuff in them too, right? You have things like cellulose, polysaccharides, tannin, or tannic acid. So you might want to find out how to separate these from the caffeine. And this is what will be discussed in this lecture. So what exactly is cellulose? Well, cellulose is basically a polysaccharide of glucose, one of the forms of glucose. To understand what a polysaccharide is, first we need to know what a monosaccharide is. So here you can see the single monosaccharide of glucose, right? It is a single molecule, six-membered ring with the 6 oxygens, right? And 6 carbons. You have 1, 2, 3, 4, 5, 6 carbons, right? This is the Hayworth projection, and here you see the skeletal form, right? And this is the chair form. These molecules, these monomers, they start forming long chains. And when they do that, that is what is known as a polysaccharide. Now, cellulose is not water soluble. The reason for this is that when cellulose, the type of glucose that forms cellulose has a certain type of bond here that does not allow it to branch, and it forms very, very tight crystals. So water is not able to hydrolyze this bond because of how tightly packed the crystals are of the cellulose. Tannin is a polyphenolic compound. It can be hydrolyzed to glucose and gallic acid. You see here. This is glucose and this is gallic acid. You see here it's pretty branched, right? So it is able to get hydrolyzed by water as opposed to cellulose, which couldn't. So all you have to do is treat this with water and you can dissolve it pretty easily. So one important thing to note here is that you'll see here glucose is pretty soluble in water, right? However, gallic acid isn't so much. Now, in order to make this more soluble in water, you would have to treat it with some kind of a base, in this case, sodium carbonate, right? And when you do that, you deprotonate this carboxylic acid here, and you form a salt. And once this becomes a salt, we know ionic compounds are pretty soluble in water, right? So that is a way to make this water soluble. And then this also forms carbonic acid, which I don't know if you guys know, but if you open a soda, you see all those bubbles. Carbonic acid, which is in the soda, easily decomposes to carbon dioxide and water, right? That's what all those bubbles are. Now, this reaction isn't balanced. It's always good to, try to figure out how to balance an equation, right? To make it correct. It's always useful, right? To know these things. So to summarize what I just went over right here, right? We have these bags of tea here, and they have all of these different components in them, right? You have cellulose, not water soluble. Pretty much makes it easier to get rid of, right? You have tannin, which is water soluble, but the gallic acid, which comes out of tannin, isn't so water soluble. But if you treat it with sodium carbonate, you make it more soluble in water to make it an ionic compound. And then you have caffeine, which is soluble in hot water and very, very soluble in DCM. So that's the summary of this. And here we see an overview of what this experiment is going to look like, right? You have your caffeine here, soluble in water, very soluble in DCM. You can evaporate the DCM and you have impure caffeine, which you can then sublime and you have pure caffeine. The cellulose is not water soluble, so that can be separated by simple filtration, right? And then you have tannin, which is hot water soluble. You can hydrolyze it in the base, make it get stuck in the water, and then extract it by using the differences in solubility and DCM, right? So I'll go over this in a bit. So here's a list of everything that will be needed to perform this procedure. You will need a 250 milliliter beaker for the brewing and 100 milliliters of water, 5 bags of tea, 1 gram of sodium carbonate, a hot plate or a heating plate, one 125 milliliter or 150 milliliter separatory funnel. Make sure that the stopper is the right size. You can see here this is a separatory funnel. It has this heart shape, right? And you have an opening at the top and a stopcock at the bottom for draining the liquid. There's going to be a separation of liquids here, and basically you'll just separate it by draining the bottom liquid out, right? You'll need a ring stand to hold this, a few clamps, 40 milliliters of DCM in 4 portions. This is to ensure that it gets properly cleaned, right? If you do 1 big portion, it's not as effective as doing 4 smaller portions. 2 right-sized beakers, one that'll fit inside of the other. And this is for the sublimation. We'll get into that in a minute. And some ice for the sublimation as well. Always make sure to put a little grease on any glass joints to prevent leaking and all of that. Don't put too much grease though, because that stuff gets everywhere. So the first step in this procedure is to brew some tea. So you take your beaker and you add your sodium carbonate and some 100 milliliters of water. You want to mix the solution well, and then add your 5 bags of tea, which should be approximately 10 grams. You would normally want to weigh it on the scale to figure out it's about 5 bags, right? You want to boil the solution for 20 minutes to get everything out of the tea bags, right? You also want to watch out that not too much of the water evaporates. If it does, make sure to add some more to maintain about 75 to 100 milliliters in the beaker. The caffeine and the tannin should be dissolved in the water with the sodium carbonate, right? The cellulose is never going to dissolve in it. So this goes on to your next step in this purification. So this next step involves the filtration, and this is in order to remove the cellulose that doesn't dissolve in the water. Now, this step is a little bit dangerous because you want to keep the water inside of the beaker hot. So it'll probably be pretty warm when you're filtering it. You don't want to burn yourself, so be very careful. You set up your Buchner funnel above your Erlenmeyer flask, right, with the vacuum outlet. And you also want to make sure everything is clamped down securely, right? And you want to make sure that these are the correct size. Otherwise, there won't be any vacuum. So you basically just turn on your vacuum. You take your hot liquid and you filter it through the filter paper, right? Also, make sure your filter paper is the correct type of paper. One other thing to note with this step is to make sure you're using the right tube. At UTEP, this tube isn't the right one, because this will just get squeezed like a straw when you're trying to drink a thick milkshake. You want to use one of the thicker tubes with the vacuum in order to make sure that nothing gets clogged up, right? And so basically you just make sure you filter everything and collect your cellulose here, and you save this liquid down here. So once you've done your vacuum filtration, you should end up with the brown liquid, which should contain your caffeine and the tannin. You want to transfer this into your separatory funnel right here, right? Also, try to use a funnel or something because you don't want to get grease into your product. But yeah, add your solution into the separatory funnel. Add the 10 milliliters of DCM, again, trying to avoid the grease on the joint, right? You then want to turn this gently back and forth, right? Opening up this while it's pointing upwards to avoid getting grease in your solution. The reason you want to open this is to relieve the pressure because DCM, when it's agitated, it produces a lot of fumes and you don't want this to burst open. So you want to release the pressure. Also, you don't want to shake too hard because you'll end up forming what's called an emulsion, which is basically just a bunch of bubbles of the two liquids into each other. And that's very difficult to get rid of. It takes a very, very long time for those bubbles to go away, right? So you basically want to shake it. What you're doing is you're taking the DCM and you're mixing it with this aqueous layer. And you're basically pulling out the caffeine, which is very soluble in DCM, from the aqueous layer. And that's basically to make sure that you only have caffeine here, right? Which is the most soluble thing in the DCM. Once you do that, you want to take out your DCM through this stopcock, right? You open it and you drain it. Be very careful not to get any of the brown liquid in here, otherwise you'll have to do more steps in order to purify it properly. But yeah, that's pretty much it in terms of this extraction, right? Also, you want to repeat this 3 times because it's always better to have small amounts multiple times than to have one big amount one time, right? That will get you a better yield of product. At this point, you should have your desired caffeine in the DCM layer, which should be completely colorless. Now, if for some reason you accidentally drop some of the brown solution into your colorless DCM solution, there's more steps you have to do. So the first step is you want to dry it with magnesium sulfate, anhydrous magnesium sulfate. The way you use this is you keep adding the magnesium sulfate until it stops clumping and it just forms powdery. The magnesium sulfate is basically sucking out all the water from the solution, right? And then once you do this, you should only have the insoluble tannin, which you can remove by a simple gravity filtration, right? And so you basically just pour your DCM, which should have caffeine dissolved in it. The dissolved caffeine should be able to pass through the filter, while the tannin stays on the filter because it's insoluble in DCM. And once this step is complete, then you have your purer solution of caffeine. Of course, there's likely to be other things in it as well, but it should mostly be your caffeine layer, right? But that's exactly why we need sublimation, to purify the caffeine further. So the next step is the sublimation, right? This step involves heat. So what you basically want to do is you take your solution of DCM, you want to heat it until all of the DCM has completely gone from the product, right? Once all of this product is all the solvent is gone, you'll see some white product on the bottom, right? Then you want to put your beaker with ice. You fill this with ice, right? The smaller beaker, and you hang it on the sides walls of the bigger beaker, which contains your product. The thing with this is you don't want to put ice in the smaller beaker until right before you put the beaker in this other beaker, right? The reason for this is because when you have ice in the beaker, there's vapor in the air, right? And it's being collected by the cold glass. You don't want this condensation to get into your solution, right? That's why you want to put the ice at the very last minute. This same the reason is what causes the caffeine to stick to the beaker because it's cold, right? So basically, you're gonna heat up. Once it's all heated, put your ice in here. You'll start to see that vapor start rising from the solid here, right? The reason for this is because rather than boiling or melting, sorry, the caffeine doesn't melt, it directly turns into gas, right? and that is what is called the sublimation. Once it's from solid to gas, it's sublimation, and then it touches the ice, which is cold, and it turns directly back into a solid, and that is what's known as deposition, right? You're depositing the solid onto this ice wall. And that's basically what the purification through sublimation is, right? You're basically vaporizing your solid and recollecting it right above in a cold environment. And you should have from here purified caffeine. Now, you really want to be careful with water, right? Because otherwise, you're not going to get many crystals to form from the caffeine. So be very careful not to have any kind of water on this ice beaker. If it does contain anything, please wipe it down before you put it in to the bigger beaker so that you can get a good yield of caffeine. As I mentioned in the last slide, water is your worst enemy with this experiment, right? Please make sure the smaller beaker doesn't have any water at all. It'll make your experiment fail. Also, if your DCM layer had any water in it, it might fail too because it'll be boiling off and getting stuck to the smaller beaker, and you don't want that either. So this is the main thing to watch out for with this experiment, right? Just make sure that there is no water anywhere in the system. All right. So yeah, that's pretty much all there is to this experiment with the extraction and sublimation. And of course, this slide shows a demonstration of how it'll look, right? You'll have your heating solid here in the bigger beaker, and you'll start to see crystals start forming on the smaller beaker just because there's ice inside of it, right? Because it's cooling down the vapors and collecting whatever's in those vapors. And one other thing to note is the dial should be at 100, which is very high heat, right? In order to make sure that the caffeine sublimes and then redeposits on the ice, right? And as always, please make sure to clean up after any experiments, right? Caffeine, magnesium sulfate, sodium carbonate, they all go into the solid waste container, right? If you broke anything, throw it in the broken glass container. All the liquids used for the extraction of the tea, I know it's just tea, but it still goes into the aqueous waste because you added chemicals to it, right? You added sodium carbonate and all that. And you use the glassware, which contains chemicals as well. And of course, DCM is considered halogenated waste, so it goes into the halogenated waste container, right?